Okay, let's look at how atoms join together, and we're interested here in ionic bonding. Ionic bonding always involves a metal and a non-metal, and here's why. Let's look at a nice simple metal. Let's look at lithium. Here's a lithium atom. I'm not showing the nucleus of the atom, I'm only showing the electrons. Lithium has got atomic number 3. That means it's got 3 protons in its nucleus and also 3 electrons. It's got 2 in the first shell. The first shell can only contain 2, so the third one goes into the second shell. So it's got this lone electron here, and for atoms to be at their most stable, they need full outer shells. Now, this second shell can take a maximum of 8 electrons. So it's got 7 spaces. So it could gain 7 electrons from somewhere, or it could simply lose this 1 electron and then it would have an empty shell there, and so all the shells that have got electrons in would be full. So where's that electron going to go? Well, actually it could do with going to an atom which needs to gain an electron. So here's, let's say, a chlorine atom. Chlorine is atomic number 17. It's got 2 electrons in the first shell, 8 in the second shell, and 7 in the third shell. So it's got this one gap, and if it filled up that gap with an electron, that would mean that it's got a full third outer shell. So this is in fact what happens. Lithium is able to give away an electron, so completely lose an electron, so that it goes onto the chlorine atom and fills that gap that the chlorine atom wants. Now, oh, look what's happened. The chlorine, because it's gained an extra negative electron, it's still got all its 17 electrons it started with, and it's got its 17 protons. It's now got one extra negative charge, so overall the thing has got a negative charge. We call this a chloride ion. I've shown the electrons as dots and crosses here just so you can see what's going on, but of course the electrons are all identical. You couldn't tell them apart. Now, going back to the lithium has got a positive charge now. The lithium ion, an ion is an atom with a charge, the lithium ion has got a positive charge because it's now lost 1 electron. It's still got 3 positive protons in the nucleus, but now it's only got 2 negative electrons. So 2 negatives, 3 positives, overall it's got a positive charge. So because the lithium is positive and the chlorine or chloride atom ion is negative, the two are attracted together. Opposites attract. So this would be lithium chloride, an ionically bonded compound between the two elements containing a metal, lithium, and a non-metal, chlorine. Let's look at another example. Let's look at sodium. Sodium is in the same group as lithium. It's atomic number 11, and you can see it's got 2 in the first shell, 8 in the second shell, that's 10. Those first 2 shells are full, so the 11th electron goes into the third shell. Just like lithium, 1 electron in its outer shell that it would like to lose. So let's say it encounters a fluorine atom. A fluorine atom has 9 electrons, 2 in the first shell, 7 in the second shell. It's got 1 gap, like all the halogens, it needs that gap to fill. Now, this lone electron on sodium, as you might guess, is lost from the sodium and gained by the fluorine atom. However, because this electron here is further away from the sodium nucleus, remember it's the positive charge of the nucleus that holds the negative electron in place, because it's further away, and also because there's the shielding effect of 2 shells in between this outer electron and the nucleus rather than just the 1 shell for lithium, it's a bit easier for this electron to be lost, and so therefore sodium's a bit more reactive than chlorine. Now, as you might imagine, this electron goes into that gap in the outer shell of the fluorine atom, so now we have a sodium ion and a fluoride ion, and the two are attracted together because opposites attract. Now, it's slightly easier for this electron to go into the fluorine atom to form the ion because it's the opposite of what I just said for the sodium. It's a bit closer to the nucleus than it was in the chlorine atom, and also there's fewer electrons between the nucleus and this extra electron coming in to shield it from the positive charge of the nucleus, so it's a bit easier for fluorine to gain that electron. Therefore fluorine is more reactive than chlorine. So here we have sodium fluoride, another ionic compound. Notice it's between a metal and a non-metal. Let's try a different one again. Let's try an element from group 2. Let's try magnesium. Magnesium is in group 2, and like all group 2 elements, it's got 2 electrons in its outer shell. To get that outer shell full, it would like to lose those 2 electrons, and so it needs a non-metal to receive that. So let's have another fluorine atom. You can see here's this fluorine atom just like before, with one gap. It's got 7 electrons in the outer shell. It'd like to gain 1 more, and then that shell would be full. So magnesium is able to give away that electron to the fluorine atom. So we've now got a fluoride ion. That fluoride ion is pretty stable because it's got full electron shells. However, the magnesium is not quite stable yet because it's got a lone electron here. It needs something to receive that remaining electron there. So in fact, as you might guess, what happens is another fluorine atom is needed to gain that electron, and so we now have 2 fluoride ions and 1 magnesium ion. Hence the formula for magnesium fluoride is MgF2, because I need 2 fluorine atoms to react with 1 magnesium atom. Right, we'll just do one more. Let's look at oxygen, which is in group 6. Oxygen has got 2 gaps in its outer shell. It's got 6 electrons in its second shell. So where might it fill those electrons up? Well, let's say a metal comes along. Let's have a lithium atom. Here's a lithium atom with its lone electron in its outer shell. It loses that electron, and the oxygen atom might gain that. The lithium atom is now stable. It's a stable ion with full outer shells. The oxygen, however, still has 1 gap to fill, so it needs another electron to fill that up. It will receive that, as you might guess, from another lithium atom. So along comes another lithium atom, which is willingly losing that electron to gain itself a full outer shell, and now the oxygen ion has a full outer shell, and it's gained 2 electrons. Because it's gained 2 electrons, it's got 2 more than it started with. That means it's got a -2 charge. So the formula for lithium oxide, which is what this substance is Li2O, because there are 2 lithium ions for every 1 oxygen atom. This is called ionic bonding, and those diagrams you see there on the screen are known as dot-cross diagrams. You may be asked to draw those in the exam. The dots and the crosses represent electrons. Remember, the electrons are all the same, but they're shown as dots and crosses so that you can see where they've come from.